Hello everyone, welcome to the solution of LeetCode problem 1442 named count triplets that can form two arrays of equal XOR. Okay, now in this problem, we are given an integer array and we want to select three indices such that I and j and k, where the value I must be less than the value j, but the value k must be greater than or equal to the value j. That means the value j and k or the second and third index can be equal. Now, let's define a and b. So here, a is the XOR of all element from I to j minus 1 and b is the XOR of all element from j to k. Now, we have to determine what is the number of triplets I, j and k where the value a and the value b is equal. So this is the problem statement. Now, in the example 1, we can see that the array contains 5 elements, which is 2, 3, and 1, 6, and 7. So here, there are 4 triplets, which is 0, 1, and 2. This 0, 1, and 2. Here 0, 1, 2 is index number. Similarly, 0, 2, 2, 2, 3, 4, and 2, 4, 4. This is the basic problem statement. Now, the array length can be in between 1 to 300, and each of the array element can be in between 1 to 10 to the power 8. Now, one intuition is as the array length is relatively 0, then here we can perform the big O of n square solution. This intuition will be helpful in the after section. Now, I hope you understood the problem statement. Now let's move on to the algorithm. Here, let's understand the problem statement deeply. Suppose this is our input array and this array contains several elements. One is this, another is this, another is this, and so on. Okay. Now, we have to find the triplet I, j, and k such that the value a and the value b will be equal. So here, what is the value a? The value a is equal to the XOR of all of the element from I to j minus 1, which is the value a. Now, the value of b is equal to the XOR of all of the element from j to k, which is represents by the value b. Now, we have to determine how many of these I, j, and k triplet available such that a is equal to b. This is the problem statement. Here, in the first example, if we see that the index number starts from 0, 1, and 2, so here, the XOR of the element 2 will be 2, and the XOR of the 1 and 3 will be 2. So both of them are equal, so it is one possible triplet. Now here again, let's write it again. So here, the XOR of 2 and 1 is 3, and the XOR of element 3 is 3, and both of them are equal. So it is one possible scenarios. So here we can see that in the example 2, 1, and 3, there are 2 possible XORs. Okay, so far, so good. Now, if you read the problem statement carefully, then you will find that we have to find that whether there is any division possible in the subarray such that both part of the subarray have the equal XOR value. That means The problem basically asks that if there are any division possible such that both part of the X subarray will have the equal XOR value. Now, if both of the part have equal XOR value, that means the XOR of total array is equal to 0. This is the basic intuition. How this comes from? Here, we know that according to the truth table of the XOR, if the value A and B is 0, then the output will be 0. And the value A and B is 1, and the output will be again 0. That means if both of the bit is equal, the output of the XOR will definitely 0. So here, if the left portion's XOR of all the element is A, and the right portion's XOR of all the element is B, and if A and B is equal, that means the XOR of all of the element covering these two subarray will be is equal to 0. This is the basic intuition. Now, how can we solve this problem by using this intuition? Here, suppose we are given an array which has this element. It can be anything. Now, here we will use the nested loop. That means two loops. One loops will iterate from the first element, and the next loop will be the next element to the last element. And we have to perform the bitwise XOR in the range. And if any of the range has the bitwise XOR value is equal to 0, we have to simply add the value of j minus I. How this comes from? This basically comes from, let's understand these examples, which is 2, 1, and 3. So here, the XOR of 2, 1, and 3 is 0. So here, we have found two divisions. One is this. That means 2 is one subarray, 1, 3 is another subarray, and another is this. 2, 1 is one subarray, and 3 is the another subarray. So here, we have found two division, and these two basically comes from the subtraction of the index number 2 and index number 0. This is equal to 2 minus 0. That means 2. So here, suppose this is the index number I, and this is the index number j. And if for any of the range I and j, if all of the values XOR is equal to 0, that means we have to simply add j minus I to the answer. And after completion of this two nested loop, we will find the answer. And here, as we are using the nested loop, the time complexity will be big O of n square. I hope you understood the basic intuition behind the solution. Now let's move on to the code. In this problem, the code is pretty simple. At first, we are given a function named count triplets, which has a vector as a parameter. Now here, one variable answer is equal to 0, and the variable n is a dot size. Now here, in the outer loop, we are iterating from 0 to n. And here, the XOR value will be a of I. And in the inner loop, we are iterating from I plus 1 to n. And each time, we are performing the XOR operation. Now, if the XOR value is equal to 0, we have to add j minus I to the answer. Finally, we have to return the answer. I hope you understood the code. Thank you everyone for watching this video. We will get back soon with another LeetCode solution.